Welcome back to the 2019 Section C Geological Geometry question C-1. Okay, so on the accompanying map, so we've got the accompanying map here, it will be in the back of C or Section A in your actual exam. We have A, B, C is a centre line of a proposed track for motorcyclists, or sorry, for motor prospects. D, E, F and G is a proposed pit stop. So we've got our track here and our pit stop here. And they're telling us O is the centre of the circular curve. So O is the centre of this curve going around here. The track has the following specifications. The portion from A to B is level at an altitude of 55. So from A here to B is at 55. So I'm going to just write at 55 there, at 55 there. The portion from B to C is rising uniformly to a level of 60 at the finish line C. So this here is at 60. Formation level at F in the pit stop area is at 55. So F here is at 55. We can see that. No, we can't. So that's at 55. 55. And the gradient from F to E is the same as that on the track B to C. So this is rising uniformly again, okay, at the same rate here. So that's at 55, and that E then is going to be at 60 also, same rate. So this whole section rises at the same level. Using slopes of 1:1 for cuttings, so our cut is 1:1, and embankment is, so our embankment is our fill, is 1:2. Complete the necessary artwork. So all our sections there are going in 5 metre intervals, so we're going to have slopes there of 5, 5, and then we're going to be going up, sloping up then 5, which is going to be 10 metre intervals then for our finding our contours, or finding our fill. Sorry, to complete it necessary, that's the track and pit stop area between A and C on each side. Okay, so let's start with that. From A around to B with our centre O. So we're at 55 here, so 45, 40, 30, it's 40. So as far as this contour here, we're going to be doing a fill. Okay, we've determined that a fill is going to be 10 millimeters. So in 10 millimeter intervals, actually just draw a line out here from O through A, and we're going out in 10 millimeter intervals, 10, 20, 30. So at 50, filling. So that's 55. Five, 50. Yeah, so we wanted that. Just like that. Go again. That will be 45, 40, 35. Great. So starting 50. There is 35, so that's going to be a mark. Into 40, it's not 45, that's 40 there, isn't it? Oh, it's 35 as well. And down to 40. 45, 50. And then we're intersecting a road there at 50 as well. So that is one set of contours. I don't know where that's going to finish, but it is somewhere out here somewhere. So just extend it out. Okay, I also should have done my inside the line here. There are also going to be 10mm intervals. So we got 55, 50, 45, 40, 35. Yeah, that'll do that. So swing our X 50 down there. 45. 40, 35. So 35, 40, 45, 50, now it's my 55. That will stand down there somewhere. Okay, now once we get as far as this point, we're into cut because we're going up into 60, 65. Okay, and our cut is 1:1, so we're going to be going in 5 intervals. So just draw a line out here so I can mark off my 5 intervals. So we're at 55, 60, 65. That's all we should need. Okay, I'll just mark them there, but there's no 70. And the same on the opposite side. So 55, 50, sorry, 60, 65, 70. Okay. So no 70, so actually I won't bother marking it. There's my 60. I need. Same on the opposite side. So we're at 55. We're cutting into the hill at 60. 60. Cutting in 65, 65, 60. And back to our 55. So I can draw there. And we got 55 up to our 60, 65, 65, and 60 again and back to our 50. Okay, so okay, so I fill my cut. Now, from G to F here, or from B, sorry, out to F, that is all level at 55. So I'm going to be going, I'm going to be cutting into that, sorry, filling there, so I'll be doing 10 again. 10, 20, 30, sorry, which is 55, 50, 45, 40, 35. Let's see what we've got. Okay, so 55 there, then we're out on to 50, 45, 40, 35, 35, and this will be going back to 40 again somewhere. So it's our next bit of fill. Alright, and then we're on to our sloping. Okay, so we're going to be sloping from 55 to 60. So it's always underneath the level of the road because that's 60 when we get as far as here. So this will all still be a fill. Okay, same here. This is rising from 55 up to 60. The height of the road is always underneath it, always underneath here. So it's all going to be a fill. Okay, it's my fill cone. We're going to do radius 10. Let's set the compass just to 10 here. At E, we have our cone. Same down here at C. Okay, that's going to be running back tangentially from F and from B also. So let's measure out in 10mm intervals and okay, so that's 60 here. So that is fill, so 55, 50, 45, 40, so 60, 55, 50, 45, 40 and 30. I'm going to actually extend that on another little bit. We want these to cross, so that's going to be a 30 around there also. So starting here. Okay. So that's on that side, and we're going to do the same on the opposite side. So 60, 55, 50, 45, 40, 35. Okay, so 60, 55, 50, 45, 40, 35, 35, and so on. Okay. Okay, so that's the fill and embankments. cutting the embankments completed. Okay, and now part B. On the map, P, Q and R are 3 points on the top surface of the stratum of ore. So over here. Q and R are at altitudes of 45 and 25. So Q at 40, R at 25. And we can see R there is actually at 25. There's no reference to P at the minute, okay? The stratum has a strike of north 54 degrees west, as indicated by the given strike line. Okay, so that's our strike line, north 54 degrees west. Using the XY or X1, Y1 line already drawn on the map, so we have our X1, Y1 here. Determine the dip of the stratum of ore. Okay, so we need to determine the dip. So that is at 90 degrees. Yeah, it is at 90 degrees to my strike, as it should be. Okay, so what we want to do is we want to project out at 90 degrees to your X1, Y1. And project out R, Q, which is also containing the strike. I'll project out P as well, because I'm sure we'll need it at some point. Okay. Now R is at a height of 25. Okay, we'll treat that as our XY. We'll use R as our XY line. Yeah, just as a reference line. Okay, technically we could be going up, measuring up 25, but it's just taking up space. So height of 25 there for R, which we're actually, like I said, we're taking up there. Q is at a height, it says in the question, of 40. Okay, so Q, which contains the strike line, is at a height of 40. Now we're at 25 here, so 25, if you imagine we're going up in levels, right? We've skipped from 0 all the way up to 25, okay? So we don't need to count all that 25. We're only going the distance between R and Q, which is 15, okay? So 25 taken away from 40 is 15, so that's the position of Q. So R, Q. Okay, and determine the strike. That is, sorry, not the strike, determine the dip. So that's our dip angle there. Okay, and I'll measure that angle. Which is 40 degrees. Okay, so you can have 40 degrees in there. Right, so we've determined the dip. Find the altitude of P in the space provided. Sorry, in the space provided at the top of the map, so up here. Draw the elevation of the triangle portion of this top surface of the stratum. R is already given to you. Okay, so good thing that we projected out P there. So we want to find the height. This is finding an edge view of this plane, PQR. So here is that completed edge view. So that then is the position of P. So that then is the height of P. Okay, the height of P. So let's continue on here. I've got my 25, so we've got 30, 35, 40, 45. Just mark all these off. 35, 40, and I know Q is contained on that height, 40. Okay, right, so now we need to find P. P is going to be in this position. It's a bit of thinking in this one now, you really need to understand what you're doing. So P is in this position. Here's R. So R is on the XY line. So that's the height of P from R. So R is at 25. There's my point P. So we can draw that triangle in. Okay. Yeah, so we've drawn the triangular portion there. Right? Okay, so they haven't asked us to find the altitude of P. I suppose I found the altitude of P there. If you wanted to actually measure it, you could. Right, so determine the true angle between the line PR and the strike line. Line PR and the strike line. Okay, so here's our strike line. True angle between. Okay, so we need to find the true shape. Yeah, we need to find the true shape of this surface of the triangle. So two ways we can do it. We could rotate it down, bring it back down, show it there, or we could do a true shape using a second auxiliary. I'm going to use a second auxiliary just. I think it's a little bit messy if we get into a drawing on top of a drawing. I prefer a second auxiliary. So, there we go now. Let's speed up this a bit. So that is my X2, Y2. X2, Y2. Projectile R, Q, and of course P. I'll just take distances back then from our X1, Y1 to there, so that is quite a distance. You know, it wouldn't probably fit on the page if I took the distance from X1, Y1 to Q, probably come off the page. So I'm actually going to take the datum, put the datum on P. The datum. Okay, so P then is going to be on the XY line because it's on the datum. The distance for R is from the datum to R. The datum to R. There's R, there's P, and Q, and step off to Q. they're asking for the true angle between P, Q, and the strike. And the strike is there. There's a point here of the strike. So this is the strike line. So the true angle, if I was to measure it, I've got that at 93 degrees. Okay, 93 degrees, RIT. 93, excuse me, now let me check that again. Right, 97, 80, 83, sorry, 82 or 98. Okay, 82 or 98. So that's the true angle there, and index there. So that's quite a bit in that question in terms of your part B there, covering a lot, asking you to really understand what you're doing. Okay, so that was a geological geometry question 2019.